Okay, hi everyone. Good evening and welcome to today's session. So today we are going to talk about the art of data visualization using Bayes R and ggplot2. So this is part of the R4 data science course sponsored by Department of Statistics, University of Kerala. Great. So we'll get started with today's session. I'll share the screen as well. Okay, okay. Now I hope the screen is visible. Great. Yeah. Okay. Today first we will start with the art of data visualization. Why we need the data visualization or why it is important. As everyone know, data visualization is an essential part of data analysis. Why data visualization is important? Simply a figure can explain a thousand words. Okay, so that is the power of data visualization. um, and that is why we are more focusing on the data visualization as part of the exploratory analysis and all. Okay, now when it comes to data analysis, first we gather the data, and then we explore the data. Okay, that is the first thing we will do. We will explore the data. Now, after the data exploration, we will get some insights, and then we will simply go to inferential statistics. We will have some hypothesis, and then based on the hypothesis, we will do some statistical inference and all, and we will come with some conclusion, and based on those conclusions we will move with the further thing, that is data analysis part, or we call it as predictive analytics. And after the predictive analytics, we will simply do the prescriptive analytics. So these are the 4 points we usually have. Okay, these are the four different type of analysis we usually have in the industry, or while data analysis. Now, when we start with the data analysis, as I mentioned, first thing is exploratory analysis. So data visualization is often described as the bridge between the technical analysis and actionable insight, while the science part that involves statistical or statistics, mathematics, or other computer algorithms. And okay, okay. Now, while the science part is most of the or it is mainly dealing with this art thing, or technical thing like statistics and algorithm, and the art actually lies on storytelling, design, and human psychology. If you break down the art of data visualization in data analysis, first thing we will say like the psychology of perception. Okay, so great visualization respect how the human brain process the information by leveraging the um, pre-attentive attributes. You can guide a viewer's eye to the most important data points before they can consistently think about it. So it may include the color, contrast, and also if you look at the Facebook logo and also or Facebook layout, it's mostly designed for the people who, or it is also taking into account the people who have color blindness and all, so they can mostly see the blue color. So color and contrast, that is an important part. It is using the colors to highlight the outliers, or the group of similar categories and all. That is also a part of the um, data visualization. Then the size and the weight, using the scale to denote the importance of volume. For example, using the instead of using a scatter plot, we can use the bubble chart. And also sometimes while looking at the newspaper and all, you can see the bubble charts representing some numbers and all. Okay, so that is the size and weight thing. Then we have the spatial grouping, that is leveraging the proximity to imply the relationship between the data points. Now, the second point comes to the mind is like choosing the right visual metaphor. Okay, so when it comes to the art of data visualization, the art is knowing which chart type or which plot type is best represent the underlying narratives in the data. It is not just about the looking good and all, but it also communicate the truth most effectively. Okay, it explain what is the truth more effectively. So here we will do the comparisons, trend analysis, distribution analysis, relationship, like these kind of things. So for comparison, we will be using the bar chart or bullet graphs or bullet charts and all for clearly rank the weights or rank the data and do a comparison of different category or different ranks and all. Now, next one is trend. Okay, so we'll be using line charts and all to show the flow of the data over a time. Mostly in time series data and all, we will be using a we'll be using a line plot that will simply represent how the data is changing over the time. Then we have the histogram and box plot or violin plot, which reveal the shape and spread of the data. So we call it as it will explain the distribution of the data. Now the final one is the relationship factor. So using scatter plots or bubble plot or kind of some scatteredness related plots that will help us to show the clusters and the correlations in the data. Now, if we have both these part, one is the psychological part, and second is the choosing the right metaphor. Once we have both of these things, then next thing is narrating the flow, or we call it as data storytelling. Okay, storytelling or narrative. Okay, so it simply shows us how we narrate the data. Okay, how we narrate the things and all. So it simply shows that one. Okay, so when a raw data is collected, it is actually a collection of fact. Raw data is often known as the collection of different fact. So raw data will have a lot of information or points from the data. So we have the raw data, but we cannot directly analyze the raw data. Okay, so sometimes when we have the raw data, which is the collection of information or fact, when we turn the data into visualization, it turns those fact into a story. Okay, so that is one of the important part in data analysis process. So data storytelling or narrating the flow of the data or the flow of the story, that is very important. So we call it as or we classify these things as the hook. Okay, first thing is the hook, that is starting with the clear headline that states the main takeaways in storytelling. So next one is con content. Okay, uh, while adding the annotations to explain why a spike or dip actually happened. Okay, in the data. Then simplification, like removing the chart junk, like excessive grid lines in the data, or some effects in the data, maybe kind of 3D effects. And also sometimes when we look at some project reports and all, from students and all, we can see some data visualizations having 3D plots and all from Excel, or they are taking the different kind of fancy plot options and themes. Uh, they will take usually from Excel and all. It's readily available. So, and they take the black and white printouts and all. Okay. So when we look at the outputs and all, it will be look like a very kind of odd, like, or it's the odd one out of kind of things. So we need to ignore those kind of things. We need to follow the simplified way of visualization by removing the chart junks. Okay, we call it as chart junks. That is the unwanted grid lines or excessive grid lines or the 3D effect and all, distracting borders and all, to focus on the signal, not at the noise. Okay, that is one thing we always focus. Then functional aesthetics. um when it comes to the it is the fourth part, like, when it comes to the design, it's not just a decoration. Okay, design is not just a decoration, it's a functional tool to clarify some fact. Okay, so there we need to consider the color theory, like using the accessible palettes, like mostly when we prepare the data analysis outputs or visualization, even the mm, it actually depends on two things. One is your organization themes and all. um, Based on their theme there will be some palettes already there, so that is one thing. And second and most important thing is the color blind friendly design. Okay, so it should be color blind friendly because sometimes the um, people in the management or people we are showing the output, they might be color blinded people, so we have to take care of that also. And how we should avoid the rainbow effect, okay, which can confuse the viewer with some like decorative things and all. It might confuse the viewer um, rather than just understanding the fact from the data. Then typography, using a clear hierarchical font to distinguish between text, like title, access labels, and other labels and all. Okay. Then white spaces, allowing the data room to breathe. Okay, not so like when we give some white spaces or the we call it as the room to breathe, then the data will have or it won't be feel overwhelmed when we present the plots. Then the final thing is the ethical dimension. So the art of visualization comes with the responsibility of integrity. So aesthetic choice should never distort the data to fit a bias. Okay, so two things we usually look into the ethical dimension, like avoiding the distortion and transparency. Okay, so while avoiding the distortion, we usually put ensuring the access starting at zero where appropriate, and maintaining the consistent scale throughout the data points, and transparency, clearly labeling the source and acknowledging the missing data or the sample size and other related things. So, why the data visualization matters? In data analysis, a brilliant insight is useless if it cannot be communicated properly. So, the masterful visualization that ensure the complex findings and accessible, memorable, and perceived to stakeholders who may not have a technical knowledge or technical background to the data analysis. So that is the introduction or importance of data analysis, or the art of data visualization. So we will be discussing the art of visualization in detail when it comes to that particular module. But before that, for an introduction, I just mentioned these things. And now We'll be looking at the data visualization using basic R plots and ggplot2. Okay, so ggplot2 is the R package that is known as the grammar of graphics. Um, so ggplot2 is a data visualization built on the principles of the grammar of graphics, uh, and it provides a systematic way to describe and build graphic using layers, aesthetics, and geometries. It often gives us a lot variety of data visualization options, and it will cover most of the 2D format of data visualization, and it's suitable for most of the statistical data representation and all. And it also allows us to creation of the complex and multi-layered visualization by combining different components together. And our community is nowadays also very much comfortable and finally using the ggplot2, which will create the publication quality graphics as well as the um corporate quality graphics. Now ggplot2 is now part of the tidyverse environment system. So we already discussed about the tidyverse environment system, and uh, it is a collection of R packages designed for data science. Now, when it comes to ggplot2, the key concept is first we need to have a data set that is being visualized, and then we need to have the aesthetics, or we call it as ACE in ggplot2 language. So ACE is actually mapping the data between variables and visual properties, like what is the x-axis, what is the y-axis, which variable represent the color or size of the plot and all. Then we will have the geometrics, like we call it as geom in ggplot2 language. Geom represent as the visual representation of data points, how to represent the data. It, it should be in points, or it should be in lines or bar, etc., etc. Now, then we have the facet, that is creating multiple plots based on the subset of the data. And also we have the themes. Theme help us to create different themes. There are already some standard themes are available. Either we can use those themes or we can simply create our own themes. Now the basic structure of the ggplot2 will be, first we will using the function ggplot2, and which initialize the plot and the data and aesthetic mapping. Then we add the layers using a plus operator. Here we won't use the pipe operator. We use a plus operator. Sometimes in a coding interview and all, you can get this problem. Uh, just get this question to correct the question, like instead of they might be represent, instead of plus they might be represent the pipe operator, and then ask you to identify the issue or error in the program. So most of the people are failing there because they think okay, pipe is suitable, they will think about some major issues, so there won't be anything. Okay, so that one. And one example is this, like ggplot2 data, we call the data set here aesthetic, we provide the x variable and y variable. Then the ggplot part completed, and using a plus symbol you can add other part like uh, geom point and the theme, facet, and etc., etc. Okay, so there are few other options available, so we can discuss those things. Okay, now okay, now now we will move on to the hands-on coding part. So first, we have already explained the power of visual exploratory data analysis. Uh, so ggplot is already having some industry standard level interactions, and also that's why we use the ggplot too. So before starting with ggplot2, we will start with the transition the basic R graphics. So in basic R, we have the plot function for creating the plot. Okay, so we'll use an example here. Okay, so we will have a empty car data set. So let me split it. Okay, let me split this up. So we'll have an empty car data set. It's a built-in data set that explain the details of a car. So before that, let me clear the environment. And okay, so first we'll check the empty cars data set. So data. Okay, so empty cars is a built-in data set in R, and you can see the data here. Like this is the data set. So this is actually explaining you the different car type and mileage per gallon, cylinder displacement, horsepower, drag, weight, etc., etc. Okay, so number of gears and all. So all these details are there in the data. So um, we can do a plot. Um, we can do a simple plot using a plot function. So plot function, we will have the plot function, then we will pass the x variable, y variable, then using main, we'll give the main title and x lab for x label, y lab for y label, and pch and color. Okay, so okay, so once we give these instructions, what we will get is like we will get a plot like this. Okay, we will be getting a plot like this. So basically when we run a plot, it will show us in the plot area in this files tab. Okay, so this is how we generate a simple plot. Okay, so we'll see one simple example. Okay, so we'll create a data set, data one, that will be equal to. Okay, just creating some random data. So data one category, I'm representing A, B, C, and each will repeat it 10 times. So there will be 30 observation. Then values, I'm creating some random normal distribution values. So I'm creating 10. R norm function is used to create the normal distribution values. So R norm, okay, for normal distribution value and with mean 5. Then mean 7 and mean 6. So I'm creating three different categories based on this. Okay, based on different mean values. Now, once I take the data one, my data will be look like this. Okay, I'll have two variables, category and values, and it will be having different values as well. Now, I wanted to plot this data. I can use the plot function. So data one category, uh, then data one value. So main, I can say it should be a box plot. Okay, and xlab. Okay, or we can remove this part for now. Okay, okay, I can just simply create a plot using plot data of x variable and y variable. Okay, so let me put this one. So mm, finite excellent value. What is that? Mm. Mm, next code n is introduced by collection x limit value. So okay, first we will just plot this one itself. Okay, first we will just plot this part, data and category. Okay, it's showing some finite y limit value, so we can give some y limit value. So let me, okay, so it's showing some x limit. So let put x limit equal to, okay, some limits. Let me apply some limits. Okay, so let me apply some limits here. So I'm putting x limit and y limit. So I'll be getting a plot like this. So here nothing is actually showing. Why it is not showing? It's category. Okay, it might be represented in category character only. Yeah. So okay, let's put as dot factor. Okay, it should be a factor. So okay, now we are getting this one. So it actually takes those values as individual values. That's why it's showing that error for x limit and y limit. Okay, now let's remove this part and see. Okay, so now we are having this one. Okay, so I have the plot. I just plotted the category and value. So I'm directly getting a box plot. I'm not defining anything here. Like I'm not defining like I need something like a box plot and all. I'm simply doing a plot here. If I simply put the category, it will create a bar plot. So if I use a y part as well, like data value also, so I will get the, okay, I'll get the box plot. It's automatically triggering. So to one factor variable and one continuous variable is there. So it's taking the box plot. And now I can add a couple more things here. One is the color part. Okay, color equal to, I can put some green color here. Okay, so green color, it will show a green plot. Okay, the box will be filled with green color. Now I can also put the main, okay, main title, y label and x label. So here I will get the title as the main title, and x label and y label I will get. Okay, so this is how we get the, okay, we get the plot. We can update the plot like this. So it is actually starting from 0. Y limit is actually starting from 0 to somewhat around 10. So if we need to update or we need to put y limit, okay, y limit should be something more. I can simply put y limit equal to 0 to, instead of 0 to 10, I can put 0 to 20. Okay, so it will create a y limit of, so you can see the plot is actually changing from 0 to 20. Okay, y-axis is changing from 0 to 20. Now let's put 12 instead of 20, so it will be having a better visualization. Okay, so now we have this plot. Now this is the plot we have created here, and also I can change the PCH and all. So PCH, let me put 9, so it will change the points, point shape and all. Okay, you can see PCH is actually changing the point shape. So PCH argument is our plotting function, and stands for the plotting character. Okay, that is PCH, plotting character. Okay, so it is having values from 0 to 25. So based on 0 to 25, you will get some different values and all. Okay, so you can change any values from 0 to 25. So if I put 0, I'll get this one. Okay, so similarly I can put any values between 0 to 25. If I put 26, it will show an error, like so it won't have a value 26. Okay, let's keep it as 6. So this is how we will get the basic plot. Okay, now once we have the basic plot here, what I can do is I can either zoom the plot. Okay, so once I zoom the plot, I will get some plot like this in a separate window, so I can get it into full screen and all. So that is how I can zoom the plot. Now, I can also export the plot into different format. Either I can save as image, or I can save as a PDF, or I can copy to clipboard. If I copy to clipboard, I can paste it anywhere. So if you're creating some report and all in Word, you can simply use the copy to clipboard option, and if you click on that, you can actually change the ratio of the plot as well. So I'm changing the width to um, 860, and I'm changing the height to 1024. Okay, and if I click update preview, so it will update. So here you can see it is actually update based on the maximum scale. If I click on maintain the aspect ratio, so once I change something, okay, it will change it accordingly. If I put 120, it will automatically update the other value. Okay, so this is very margins too large. So okay, so if I update something, it will update the preview accordingly. Okay, okay. Now, okay. Now if I don't want the height to be adjusted, let's put this one. Okay, so I'll get a plot like this, and I can copy the plot. Okay, and I can paste it anywhere, like in yeah, like in Word, or any document we are creating, we can paste it anywhere. Okay, you cannot paste it in R, so I'm just skipping that. Or you can even save the image, so you can save it as save in these format. Usually we prefer PNG format, and here also you can change the aspect ratios and all, and or you can change the ratios. You can select the directory, and you can rename the plot. Okay, and you can save it, so it will save to the directory. Okay, so here the box plot is saved, and you can open it from here. Okay, so okay, so that is how you can do the plots and all. Now this is about the basic plot. So based on the categories, it will auto change the values, or auto change the plot. So here once again I'm going with the hmm, data. So we have the MTG data here. So here we have the cylinder and MPG. If I select cylinder and MPG um, plot, okay, so cylinder, okay, so it will create a plot. Okay, it's actually having two. Okay, it will have a plot, a scatter plot, based on the number of cylinders. Okay, so here you can see uh, earlier we go like for the same data we got actually a, box plot, but here instead of box plot I am getting a, scatter plot. Why? Because here cylinder and mpg, both are the numeric variables. Okay, so here both are the numeric variables, so that's why we are getting the um, yeah, we are getting the scatter plot here instead of a simple box plot. Okay, now if I change this as dot factor of cylinder, then if I run this one, I'll get the box plot. If it is a factor, it will auto adjust. The plot function will auto adjust. It will check the variable, and based on the variable, it will auto adjust the figures. Okay, that is one advantage with the plot function. If you have any questions regarding the um, plot function, so you can simply type this one, so it will resolve the plot options. Okay, or it will give you the plot function. Okay, this is the default plot function in R. We have x and y options. Then type will be point. Okay, default type will be point. X limit, y limit, log, main, sub heading, main heading and subheading, x label, y label, uh, and all. Okay, then any annotations and all. So these are the options in basic plot function. You can explore here. So this is how we usually do the plot. Okay, if it is one variable also, we can do the plot for a single variable as well. um, Data dollar mp sorry mpg comma. Okay, so it will show you a histogram. Oh, okay. Okay, it will show you a okay, it should show. Okay, type is actually by default it is p. Okay, so we need to update this one. So oh, okay, sorry, here it will show a scatter plot only. Okay, it's actually showing a scatter plot of uh, mpg and mpg only. So yeah, so for histogram, if you wanted to put a histogram, we have a hist option. So a hist of uh, data mpg, so it will create a histogram. Okay, hist function is there. Hist function will create a histogram. Okay, and in hist function we can also put how many breaks we want and all. So those kind of things we can also put. So one more example, similar example, if I can rewrite it. So here this is an enhanced histogram. So here here we have the data empty cost dollar mpg, then main will be distribution of fuel efficiency, x label will be mileage per gallon, y label number of car model, color sky blue, border will be instead of this black border we'll have a white border, brakes will be 10, there will be 10 histograms will be there, x limit will be 10 to 35. Okay, so okay, now if I run this one, so I will get a histogram like this with the specified x limit and all. Okay, so this is a another option for histogram. Okay, similarly we have the okay, let me put it here. Okay, similarly we have the box plot. So for box plot, actually we can use the similar data. So I am putting mpg and cylinder. Okay, I wanted to see the relation between mpg and cylinder. Uh, okay, I'm putting in the main title x label, uh, then Y label, and color will be light green. For different type of cylinders, I can put different colors as well. And then borders will be dark blue, notch will be notch will be there. So we can create a his box plot like this. Okay, so this is because notch is there, so it is showing simply the notch. So if I remove the notch, then my plot will, oh okay, so I didn't close that one. So okay, if I remove, okay, comma will be there. So if I remove the notch and if I run, okay, if I remove the notch and run it, it will show the symbol box plot. If there is notch also present, then it will show simply the uh, notched version. Okay, so the plot will be little bit having a notch as well. Okay, so it is actually showing some difference in the data points here. Okay, this is about the box plot, and similarly we can create a bar plot here. So bar plot also we can create cylinder columns. I'll simply create the table empty cast cylinder. So cylinder counts it will create. So counts will be 4 cylinder, there will be 11 11 cars. 6 cylinder, 7 cars are there. 8 cylinder, 14 cars are there. Now I can create a bar plot with cylinder counts. Then main will be the x axis and y label, then the colors. Okay, and okay, side by side plot. Okay, so this is how we can create a side by side bar plot. Okay, so these are the functions available for bar plot. You can also change the colors as you need, and also put if beside equal to false, then you will get, okay, here we don't have the different type, and also that's why it's not changing any difference or showing any difference here. Okay, you don't need to create a separate variable like this. You can also put the value here as well, so it will also give you the similar plot. Okay, you can also put hex color, so there will be codes related to RBG color. So from 0 to 99 there will be codes for each color. So it will create some random colors based on the selection. 69, so it will be dark blue. Okay, so like this you can create a hexa code as well. You can use the hex code as well. So hex code you can google and you will get the colors as you need it. Okay, so every time if you cannot put the colors and all, so I think the first part will come for this one. Okay, first part will come for yellow, second part will be green, and sorry, first will be red, second two letters will be green, and third two letters will be blue. Okay, it will be like that. So if I put 1 1 2 2 1 1 5 5 2 2, okay, so it will give you a green. Okay, like this you can actually change the hex colors as well. Now okay, so this is about the basic plot options. A couple of basic plot option we have in R. So we won't much use the basic plot options and all in our day-to-day data analysis works and all. So if you have any questions till here, we can just take a pause and discuss that, and we'll proceed with ggplot2. Any questions here? Any question from anyone till here? Could someone answer if I can make sure I am audible as well? Any questions on this basic plots and all? Okay, thank you. Thank you, Anaka. Anyone else? Okay, I think you might be already familiar with these things, and so we can go ahead with ggplot2. Okay, great. So now when it comes to ggplot2, so ggplot2 is actually created with the theory that is called grammar of graphics. Okay, the grammar of graphics. Based on that theory only, we have ggplot2. Okay, so it's a theory, and the paper is available online. You can search for if needed. You can search for the components. So basically, ggplot2 will have 7 components. Oh, sorry. Okay, ggplot2. Okay, so the 7 components are basically first part will be data. Okay, these are the 7 part. First one will be data, then second one will be mapping. Okay, so mapping, it actually comes as aesthetics. We call it as mapping as well, or mapping or aesthetics. Okay, then we have um, layers. Okay, layers will be there. That is the geometrics and all. Then we have the statistics. Then we have the coordinate. Then we have facet and themes. Okay, so these are the 4 basic components of the grammar of graphics, or a ggplot2. Okay, so combining these 7 tools together, we can create the ggplot2, or we can create a grammar of graphic. Now we will see how we can combine these things. So basically, even though we have the same things, we can actually create a visualization using these 3 components. Okay, so first we will look into these 3 components, that is data, aesthetics, and geometry. Okay, now, so first thing is data. Okay, so I'm just taking an example data. Mm, so We'll take the empty cars as well. Okay, we will use the empty car as data. Okay, let's data be empty cars. And okay, so now I have the data. So I need to call the library ggplot2, that is for getting the library. Okay, so I'm loading the ggplot2 library. So once I have the ggplot2 library, then I can use the ggplot2 function. Now ggplot2, this is a function I am using, and if I put data equal to data, okay, so this will uh, sorry, ggplot2 is not the ggplot2, ggplot is the function. Okay, so this will create the first layer. Okay, this is the data layer. So you can see here it actually create a plot, but nothing is there. Okay, ggplot2 of data I have just passed, and it actually not created anything. So you might be thinking like data is something, we have 32 observation and 11 variables. So what if I put the okay, what if I put the single variable? Okay, so I'm putting data dollar mpg only. Okay, I'm just passing one single variable. So it won't accept that one. Okay, because we cannot use a dollar operator in a data function. So I am just updating this one. So data equal to, okay, let's put on, let's remove this data equal to data dollar mpg. Okay, data dollar mpg, which will return an error. Okay, so I'm just commenting this one as we already look at this one. Now I'm just assigning mpg equal to data dollar mpg. Okay, and I'm just assigning ggplot okay, ggplot data equal to, I'm just passing mpg. Okay, so this will also give me an error. So data must be a data frame. Okay, data must be a data frame, nothing else will be taken as data. Okay, so first thing is data comment, that should that should be a data frame or table format. Okay, it should be in a data frame or table format, not in any other format. That is one thing. Okay, so this will also return a error, like so I'm just mentioning here data. Okay, so here data argument expect and data frame, not a vector. Okay, so that is one thing we need to take care. Now with only this data set, it won't generate anything. It will simply create a frame like this. This is a plot frame. It's a frame. It initiate a frame, but nothing is there. Okay, so for that we need to map something. Okay, so the second part is mapping. So we need to map the aesthetics. So that will help us to map the variables to visual properties. So I am now mapping the data ggplot data aesthetics. Okay. So before that, we'll just see what is the ggplot. What are the functions in ggplot? Okay. So here you can see the visualization. Let me open the visualization. Okay, here you can see the ggplot2 details. So it will create a new ggplot. Okay, ggplot2 function will create a new ggplot, and it will have this options like ggplot data mapping. There we need to map using aesthetics. Then other arguments we can pass here, and some of the examples it's actually showing here. So what are the arguments we can put here? So examples and all, it's simply showing here. Okay, so we can use those things. Okay, for the reference you can still use those things. Okay, now ggplot2, first thing is aesthetics. So here I am giving x variable should be weight and y variable should be mileage per gallon. Okay, of the data frame, empty cast data. Now if I run this one, now there is a small change. Okay, in the data, first we tried ggplot data equal to data, so that actually created a empty frame that is ready for the image. Now if I put ggplot2 data equal to data and aesthetics, I am passing x-axis should be weight and y-axis should be mileage per gallon. Now I am getting um, a different screen or different plotting area. Like I'm getting x-axis and that is mapped to weight, and y-axis is mapped to mileage per gallon. Okay, these two things are actually mapped. Okay, now here I need to put but the plot is not yet visible, so here I need to put some other things. Okay, so next thing is actually I need to map the different layers. Okay, so layers can be um, or the layers is also known as the heart of any graphics. Okay, in ggplot2, so there it can be three type of layers can be incorporated. Okay, first one should be geometric. Okay, so I'll put first one should be geometric objects. So geometry that determine how the data are displayed, such as points or lines or rectangles, etc. Then second one will be the statistics. Okay, statistics. It can be any statistics information like maybe we compute a new variable from the data or affect what of the data is displayed, etc. Now third one will be the position. Okay, adjust the placement of the elements. So also some coordinate adjustment and all, everything will cover under the position adjustment itself. Okay, so that is a position. So these three type of layers we need to incorporate to a plot. So then only we can create a plot. Now mm, let me create this one itself. So okay, now I'm using a plus. I'm connecting to a geom point. Okay, I'm creating a scatter plot. So creates a scatter plot. So for that I'm putting the geometry as points. Okay, so the geometry will be points and it will create a scatter plot. Now if I run this one, you can see it actually create the plot. Okay, it actually create the plot like it's a scatter plot. Okay, so it is showing the relationship between weight and mileage per gallon. So you can see here, if the weight is less, the mileage is higher. Okay, so there is a relationship as well. Now here we can put another layers as well. So I'm just copying this code and pasting it here. I'm just putting a plus. Okay, so here the plus won't be work after the this one after the comment. So I'm putting geom smooth method equal to lm. Okay, so I'm putting geom smooth method equal to lm. So here you can see there is a regression line also attached, because there was some relationship with the x-axis and y-axis. So we added another geometric there, that is geom smooth, that add a regression line as well. Similar thing I can do here. I'm put the method equal to lm. So similar thing I can also do with some relationship. So y, I can put the formula as well. Formula equal to y tilde x. Okay. So y is directly related to x. Okay. This is the equation I am putting. Okay. This is the formula I am putting. I can also mention this formula here. So based on that, it will create the regression line as well. Okay. So based on a formula. So it add a regression line based on this formula we have provided. If there are multiple variables and all we need to consider, and we need to define some formula, we can use this method. Here we only have x and y, so there is no issue with that one. Okay, that is how we can put the different methods. Um okay, I'm just deleting this one. So okay, we'll go with the running. So now the next thing is scales. Okay, now how we can incorporate the scales here. First thing is, I'm putting the same. Okay, let me put the same data. I'm putting the same data here, and here instead of simply x and y, I'm just putting one more thing, that is color. Okay, so color equal to, I'm putting some variable called cylinder. Okay, okay, cylinder. I'm putting cylinder as a color variable, and I'm putting okay, I'm putting geom point, so I can create a scatter plot only. Now I can scale something. Okay, scale. I can put some color scaling. Okay, so for color scaling, I can put a color gradient. So color gradient will be from low to high. Okay, so if I not put the color variant, first we will go with the this much only. Okay, if I put this one, you can see the based on the cylinder variable, it actually changed the colors. Okay, it actually changed the color based on the cylinder variable. Now I wanted to add some scale. That scale will be applicable to color variable. Okay, so that I can do it in different way. One way is using the color gradient. I can mention here, instead of dark blue and light blue, I can mention it should be low should be blue and high should be red. Okay, so based on that it will create the color gradient. Okay, so based on the color gradient we have customized. Similarly, I can also do okay, it should be plus here. Okay, I can do the color vivids as well. So vivid color scale are from vivid light, then okay. So we have three vivid color scales are there. Okay. So we have vivid color scale D, C, and B. Okay. These are the three color scale we have. Okay. So the minimal one is actually vivid D. So the vivids actually scale provide a color map that are particularly uniform in both color and black and white. Okay, so it will be having the color shades when you print it in black and white or color paper. Now here you have options like what are the names, then alpha value, begin value, end value, direction, option, and aesthetic. Okay, so these are the options here. When it comes here, you will have some more other options. Instead of these values, you will having some values or what is the space, NA value, what is the gray contribution and all. Okay, so those kind of things will be there. So we will see will have some guided color bars, and we will B will have some guided color steps. Okay, so that is the main difference on these two things. We can try with vivid D. So it is for discrete variable. Okay, this is the vivid for discrete variable. So here cylinder is a discrete variable, so we use the vivid C, that is for the discrete variable. Okay, now if I run this one, oh sorry, I selected that. uh, okay, it's not taken as a vivid D because it's not a factor. So let me update this data. Let's do some manipulation in the data. Oh, sorry. Okay, so we'll be just okay, we'll just convert the needed variables into factors. So now we have the data. So now this will work. Okay, so now you can see it is actually as the factors. It's a discrete variable. So that is acting as a factor as a discrete variable. So now we have the color scales based on the vivid D. Okay, it's a color scale for discrete variable. Now we have the other options as well. So instead of vivid D, we can use for vivid C. That is for continuous variable. Okay, so it's giving an error because it's not a continuous variable. So instead of cycle, I can put some other variable in the data. So weight already HP. Okay, we can take HP. Weight and okay. If I put a HP, so you can see based on the horsepower, it is actually changing the color scale. Now vivid B is also there. That is for okay. If I change to okay, if I change it to vivid B, then it is for binned values. Okay, it is for the binned values. So that will be binned. Okay, it will by default it is having 1, 2, 3, 4, 5, and 6 bins. Okay, so whatever values between 0 to 100, it will be having this one, and 100 to 150, 150 to 200, 200 to 250, 250 to 300, so and 300 above, so it will be binned like this. Okay, so this is how we can use the different color uh, okay, color scales and all. Okay, color scales in the point. Now the next point is facet. Okay, how to set the facets. So before that, any questions still here till the color color scales? Any doubts or any clarity, anything need to be explained again? Can anyone put a chat? So Adityan, you have any questions? You usually put some questions every day. So today you are also silent. Or I think some other guys also there. Anaka put some questions last day.
Sir, it is clear, sir.
Okay, great.
Sir, can we include more than one color panels in the ggplot?
More than one color panels. So more
Yeah.
than one color panels can be included, but not for the same variable. Okay, so
No,
instead of,
if you are including more than two variables.
if
Uh,
we are including two y variables, like two different y axes, then we can include two different color schemes as well. Okay. For a single y variable, we cannot use that one. So if we have multiple y variables, we can definitely use the multiple color schemes and all.
okay, sir.
Okay. Okay. I think it is clear for everyone, and mm, yeah. For just to clarify your question, I can do one thing like this. Okay. Um, okay. This will simply create a simple color scale with a scatter plot, and okay. Now I can also add a second set of points. That is like this is not a proper example, but as you already asked, I'm just putting. Uh, I can put um, geom point. Um, in geom point, I can put another aesthetics like mm, x equal to weight and y equal to mpg color. Color will be CYL, and instead of mpg, I can put something else. Let x-axis be the same, and instead of mpg, I can put a displacement. Okay, DISP, dispan, this one. So, mm, oh yes, okay. Okay, second layer cannot be not color name. Okay, okay. Yeah, I'll do it in this way. So here, okay, I put this one data, and instead of putting it in data, I can put it like this. CYL not found. Where CYL is not a CYL. C Okay, okay, okay. It should be inside this one. So okay, got it. Okay, so here we have two different scatter plot. So one is actually for the mm, this one. Weight and mileage per gallon, and second is for weight and displacement. So here I can put different color with it. So here I can put like this. So here instead of color with it, I can also put some color gradients instead of color with it. So let's put this one. Mm, uh, so scale color is already present. So I can do one thing, scale color manual instead of some vivids. I can put scale color manual. Okay, inside manual I can put comma. So cylinder value 2 equal to, it's a discrete one, no? C equal to okay, let's put unique data dollar CY. Okay, 468. Okay, 4 equal to red, comma 6 equal to blue, 8 equal to green. Okay, let's see. Mm, Current value for select 4 equal to, okay. So here it actually changed, and I can put the same color manual colors here as well. So here plus is needed and manual. So here I can put light yellow, light blue, light green. Let's see. Mm, Here MPG, wait, MPG displacement. Let's clear the plots and see. Okay, I think it's because of line geom point. I think geom line will work with this one. So let's see that one. No, I think there is some issue. I think I'll I'll clear it out. I think we can actually put this in this way. This is how I think we are putting. There is still some issue with the floats. So mm, why is different and okay, let me check one more thing. So I think I missed something. New, okay, new scale color. So I think that will work. New scale color is not there. Ha 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 ha. Okay, got it. New scale is actually part of GG. Okay, GG's new scale is a package. So with that package, I think we can include this one. Mm, okay. I have done it a bit earlier, but not sure. Okay, yeah. Now you can see here different scales are applied. Yeah, different scales are applied for this one. So let's see. This is for point as well. Okay, yeah, I think now it is actually working. So you can see here, like based on displacement that is here, and that is having a different scale, and this is having a different scale. Okay, so this is plot displacement MPG, right? MPG. Okay, now you can see the different scales as well. Okay, so you need to put the different names as well. So uh, yeah, this way we can actually put it in the same plot, but it should be a different y variable. Okay, I also did it a few sometimes back. I am not sure when I have done this one earlier, but not recently. That's why just a confusion. Yeah. Okay. Yeah. Thanks for pointing out that, Anaka, and yeah, I hope it is clear. Okay, great. And yeah, now now the next part is facet. So how to use the facet? Facet, actually, facet can be used to separate small multiples or different subset of the data, and it's a powerful tool to quickly split up the data into different parts. Okay, so here, okay, so if I'm using okay, this one. Okay, let's put the same one. So if I'm using this one, I'll be getting a plot like this. Okay, so I'm using the colors and MPG, x-axis, y-axis, and color, and I'm using a colored vivid scale as well. So I'm getting a plot like this. Now I wanted to add a facet, I wanted to split the data based on the gear, number of gear. So mm, okay, color instead of CYL, and here gear I can put. Okay, so based on number of gear, I can actually split the data. Which one scale? Only for continuous data. So this is okay. T. Okay. Okay, now you can see based on the different number of number of gears. Okay, based on number of gears, it actually create different yeah, different plot for each number of gears. Okay, so that is actually how we work with a facet. Now I can also do the same with multiple variables as well. Multiple instead of something into gear, I can actually put a different variable as well. So okay, instead of only gear, I can also put out the facet based on a crab and gear. So sorry, carburetor. Yeah. So here now, okay, here you can see there is a there we are getting the combination of carb and this one. So if I zoom it, okay, if I zoom it, I'll get the plot like this. So based on the number of gears and number of carburetor, it is actually showing the plot like this. Okay, so this is how we can actually update the plot. And let me see if any other sensible variable is there. 1 and 0, that is for m. Okay, okay, instead of carb I'm putting m here. So in that case, I'm getting the plots like this: 0 and 3, 0 am and 3 gear, 0 am and 4 gear, 0 am and sorry, 1 am and 4 gear, 1 am and 5 gear. Okay, based on that, it is creating the facet. Okay, this is the way we can actually create the facet based on different variables. We can also create the facet based on this formulas as well. Okay. Uh, okay. Now, next one is coordinates. Okay, how we can okay, how we can control the coordinates. So I'm using this same one, like this one. Okay, so I'm using the same formula. So here I can create a scatter plot as we already seen based on the colors and all. So now I wanted to create the coordinates. One thing is, first thing is the coordinate fixed. Okay, coordinate fixed, so it will fix the aspect ratio and it will create a based on a aspect ratio it will create. So you can see it is actually fixing the aspect ratio, and based on that aspect ratio it is actually creating the output. Now I can also change the aspect ratio. So here I can put the aspect ratios as well. Ratio zero point 0.5, so it actually fixes the aspect ratio to zero point 0.5. So you can see it is actually changing a bit. Now if I change it to 9, okay, zero point 0.9, so you can see the aspect ratio is like this. So based on increase, while the value is increasing, you can see a narrowed plot, and while the value is decreasing, it's actually having a wider plot. Okay, so that is one thing with the coordinate fixed value. Okay, now instead of a fixed coordinate, I can also update the coordinate. Okay, this is actually zoomed into the specific x limit and y limit. So here we have x limit 2 to 5, but we are only taking 2 to 4, and 10 to 30, we have 10 to 35, we are only taking 10 to 30. Okay, so using coordinate Cartesian value function, we can actually customize the Cartesian points as well. Okay, So if I run this one, I will get the specific Cartesian scale for this one. And I can also use the coordination flip as well. So instead of this one, I can use the coordination flip as well. So that will flip the coordinates as well. Okay. So it will flip the x and y axis. You can see now weight is in y axis and x is mpg is in y axis. So similarly, we have like another coordinate things like so here I can do the coordination mapping as well. So coordination map will yeah, coordination map will use the project map projections coordinate. So it will be based on the map. So we don't have a map here. Item from menu. Yes. So if we need some map and all longitude, latitude and all, we can use the coordination map. And if we have some polar coordinates, we can use the polar coordination polar and all. And if we need some transformations to x and y, any transformations and all, we can do that as well. So currently we don't have that one. So then we have the polar one. So that will convert to a polar one. So this is not installed. So yes, let me put that one. That doesn't make any use here because we don't have a map coordinate here. But still, I'm installing. I will explain it with another example, another data. Okay. So here we don't have a map, so that doesn't make sense. And polar also, it will create a polar plot like this. Okay, it will create a polar coordinate instead of a x and y axis. It will create a polar coordinate, and you can see the lowest values will be in the polar, and highest values will be far from the polar. Now we have one more coordinate option, that is actually the transformative one. Okay, okay. So trans is there. So trans will change the it will do the transformation to x and y. So here I'm changing x to log 10 and log values of x and square root of y. So it will change the plot like this. Okay, it will take the plot. So here some code transform replicated in okay, transform. Okay, latest version is transform. Uh, okay, so it will transform the values and plot it based on the transformation. Okay, so it is actually taking the log and square root of this one and just uh, plotting it accordingly based on the actual scale. Okay, so that is with the yeah, that is with the plots, coordinates and all in ggplot. Now we will discuss the theme also. The theme is the last part. So it will actually help us to customize the data in some way. So I am here using first thing is like we are not applying any theme. So we will be getting the plot like in this um, gray shade and with the um, axis grid scales and all, grid lines and all. So next thing is actually we can use the theme minimal. So it will create a minimal value. Okay, now we have the grid line, but not the background and all. Okay, so this is the minimal theme, and we also have some a couple of the themes that is already there. So another one is theme classic. It's a classic plot. It's a classic theme plot. So similarly, we will have other themes as well. So okay, Okay, instead of applying everything, I'm just showing a theme underscore. So you can see black and white, classic, dark, uh, get. So it will get some theme, active themes and all. Then gray, theme gray and all. So these kind of plots are actually available. These are the already having theme, already preset themes are there. So these are the preset themes. Um, okay, so this is actually a void theme, so it's not no x-axis, grid lines, and anything, just the plot only. So that is the theme, and we can also create a customized theme. Okay, we can create a custom theme as well. So I can put ggplot2. Okay, so here in themes, actually I can put the themes. And in themes, using the theme function, I can explain the theme, how I need the theme. Okay, so here legend position is actually on the left. I can customize it to the top. Okay, so legend position equal to top. So it will create the okay, with that symbol one, it will. Okay, it's not themes, it's theme. Okay, so it's a symbol type. So now you can see the legend is actually on the top. Okay, now I can also put this with any preset theme. So I'm just using the theme classic, and in theme classic also I can make the updates in the themes as well. Okay, now I put the position. I'm also putting the axis titles or okay, axis title element text 14 face bold color. I'm changing the colors and all. So okay, I'm changing the axis details here. So now I'm putting the plot elements like plot size and all point 0.5. Okay. Mm, okay. Okay. Now with that, I can actually create this x-axis and title. I don't have a title here, so I can put a title and all. Okay, so I will put a title as well. So here I can see the title here. So the title is there, and if I need a like subtitle, I can put the subtitle as well. Subtitle. Okay, a sample plot. I can also put the caption. Okay, if needed, caption also I can put the caption like data source, something like okay, empty cost data set, and also I can put the x value. X should be weight. Okay, so I need to put it in quotes. So y equal to um, miles per gallon. So I can put the labs like this. So now if I update the based on this, if I plot it, mm, oh, what happened? Okay, so here I can get a detailed one like so I'm having the ggplot like sample plots, title is here, all these things are there. Then x-axis, y-axis, everything is updated. And now, okay, even I can adjust the color of the title and all. So those things I can adjust. So vertical, I can put the titles in vertical or this thing. Even I can split it. I can change the line color. All those things I can make the changes. So these are the custom options we have. Now, okay, if I okay, H just is this float dot title. Okay, so it's not a plus. Okay, so forgot to put the plus symbol here, so that's why it's actually showing. Okay, now you can see it's actually height h just is actually for the position. So I put h just is equal to zero point 0.5, so it is in center. So I can put the same for the plot subtitle as well. Plot dot okay, element text zero point 0.5. So it is actually in the center. Okay, so I can update the themes accordingly. So I can create a theme as per this one. Now let me create a yeah. So these are the main components of the plot, ggplot2. So any questions here? Otherwise, we can create a final plot with all these options. Any questions before we? Okay, no. Anyone else? Okay, okay. So if no questions, I think it is clear. So now I'll show you one example. So this is an example with all the aspect added. So first is data and aesthetics. So we have added the data and aesthetics. So data is empty cast data we are taking. X-axis will be weight. Y-axis will be MPG. Color we are just taking it as a factor here. Okay, for this purpose. And now to to aspects are covered here. Second one, third one is geometry. So we are making the visual points. So geom points are there, and size I am changing, and alpha is also changing. Okay. Now the fourth one is statistics. I am adding a statistic method here. So geom smooth. So regression method, standard deviation, standard error I am putting false, so it will on show the standard error. Then the facet wrap, as we discussed, so I'm putting the facet wrap based on AM, and labeler we are putting 0 as automatic and 1 is manual. Then we are adding the scale. So continuous scale, I'm putting 9 as weight in X will be continuous, weight in 100 pounds, and limit is 1 to 6. Scale Y will be continuous miles per gallon. We are using the same limit. Then scale color brewer, I'm just selecting a pattern that is simply set one and based on cylinders. Okay, I'm giving the color coordinate a name as well. Then using the minimal theme, I'm putting the minimal theme and just updating the theme as well. So plot title, I'm just putting it bold and size increase the size with the h just is equal to zero point 0.5. Subtitle also 12 and gray, 30, that is the color, and it will be centrally aligned. Legend position will be bottom. So here we add the legend in top. Here we are adding it in bottom. Then panel grid mirror. We don't need a mirror. Strip background element. This is filled with a light gray, or I think we can put a light green. Okay, light green, and strip text will be for bolded one, and also adding labels as well. So these are the labels. Okay, now if I run with all these updates, so I will be getting a plot like this. So here you can see it's a very nice plot with publication level plot with regression lines are added to each of the points as well. So all those things. Okay, so and here also we are categorizing it into different category and all. Okay, so we have a proper publication level plot like this. Okay, so this is how we can actually create a beautiful plot using ggplot2. Okay, okay, this is how we can create a plot. So any questions so far in today's session? If no questions are there, we can wind up here. If any questions are there, we can definitely address those questions.